Welcome everybody. We're doing problem number 28 from your homework here, and we're going to have Erica walk us through this one. Go ahead, Erica, whenever you're ready.
So it says, find the dimensions of the largest rectangle that can be inscribed in a semicircle of a radius r. So it's basically asking you to find x and y in terms of r. So we know that our radius is 5. And we know that when you square 5, you get 25. So we could change this to r to represent our radius because they want it in terms of r. So we just substitute it here. Okay, so we then follow the read method, and we already read, so we could check that, and now we have to use figure out our equations. So we know that there's two separate rectangles here, and to find the area, you use base times height. We know that our base is x, or we could be represented by x, and since there's two, there's x here and x here, and we wants the dimensions for the largest rectangle, which is the whole thing. So to find our area, we use 2x, and our height is represented by y. And right here, it already solves for y, so this is our second equation. So then we could substitute this into this equation in order to solve for x. So we have 2x times r squared x squared, the square root. And then it says to find our extreme values. In order to find our extreme values, we first need to rewrite this, and we write it to 2x times r squared minus x squared r to the 1/2. Okay, now we could take the derivative, which is 2x times r squared minus x squared to the 1/2. Okay, these two are being multiplied, so we use the product rule. And the product rule is the derivative of the first times the second plus the derivative of the second times the first. Our first function is 2x, and the derivative of 2x is 2. And we multiply that by the second, which is r squared minus x squared to the 1/2. And we add it to the derivative of the second, but the second is more than one function, and so we have to use the chain rule. The chain rule says that we multiply the derivative of the outside function to the derivative of the inside. We know that this is our outside function because it's an exponent. So we move it to the front, and everything on the inside stays the same. And we do 1/2 minus 1, which is negative 1/2. Then we multiply that to the derivative of the inside. And we said previously that r is 5. So the value of this, so we don't have to take the derivative of this because this is just a number. So we take the derivative of this, which is negative 2x. And then we multiply it by the derivative of the first, which is 2x. And then we simplify. We know that you can multiply 1/2 to 2, and whenever you do that, they cancel out. So you're left with 2r squared minus x squared to the 1/2 plus r squared minus x squared to negative 1/2 times negative 2x. Because the negative there's two x's, so it's negative 2x squared. And then we can factor this out to further simplify. We factor out whatever they have in common. They both have a 2, and they both have r squared minus x squared with some exponent. So we take out the 2 and the r squared minus x squared, but they both have exponents. So we need to take the one with the smallest exponent, which is negative 1/2. And when we take this out, we're left with r squared minus x squared to the 1/2 minus negative 1/2, which is just r squared plus minus x squared to 1. And then we're left with negative x squared on the inside. Now we can further simplify this by taking whatever has a negative exponent and putting it at the bottom of the fraction. And we know that 1/2 is the same thing as the square root. So we're left with 2r squared minus x squared plus negative x squared at the top. Okay. And then we set it equal to 0. In order to get x by itself, we can multiply by the bottom to both sides. And these cancel out, and you get 2r squared minus x squared plus negative x squared equals 0. Then we could distribute this to 2r squared minus 2x squared plus minus negative x squared equals 0. Okay.